Good evening, students. Myself, N. Ramesh, presently working as lecturer in mathematics. B.Sc is SB Arts and KCP Science College, Vijaypur, and part-time lecturer in PG Department of Mathematics, Akkamadevi Karnataka State Women's University, Vijaypur. Today, we will discuss about B.Sc 4th semester RCU Mathematics. In paper 1, we have the last unit in the series, in the infinite series, that is infinite series 2 on the alternating series. Students, in the first and second part, we discussed about the positive term series. So there we studied already P series test, geometric series test, comparison test, and in the comparison test we have two types. One is comparison test for limit form and another one is general form. So we studied already these things in the first unit and examples on this. In the second unit, in the second concept, we studied about the D'Alembert ratio test, Rabe's test, Cauchy's root test, and Cauchy's integral test. So after that, in the third case, in the third unit, we will study about the alternating series. This is the very short lesson, contains same number of marks as usual in the remaining topics. So here 2 marks 2 questions and 5 mark 1 question and 10 mark 1 complete question on this topic. So before going to discuss this topic, we should know that the series, infinite series. So in that infinite series, here alternating series is a part of infinite series. So alternating series is a new word. Still you studied about the only positive term series. But here the new word alternating series. So a series with alternatively positive and negative terms is called alternating series. So you studied already only positive term series, but here in the alternating series you will have both alternatively positive and negative signs or terms. That is, if you take here minus 1 raised to n, this is the new part you studied here, new part. So summation of an, if they given summation of an, here all the terms should be positive, a1 plus a2 plus a3, so like that it is continuing on. But here a1 minus a2 plus a3, here alternatively negative and positive signs are there, therefore it is called alternating series. So where an is a sequence of positive terms. Remember, if I take an as a sequence, that sequence should be a positive term sequence. And the next definition is conditionally convergent series. Before going to this conditionally convergent series, I can see the examples on the alternating series. Already you observe here, alternating series means it is simply we can observe the examples. Then we can say it is alternating or not. So just observe here 1 minus 1 by 2 plus 1 by 3. Here alternatively positive negative signs are there. Therefore it is alternating series. So here you can observe this is the form. This is the nth form, nth term of this series. This is the infinite terms. Here infinite terms are there. Here the second example is I am taking the nth term in the infinite series. So that is minus 1 raised to n and n divided by n plus 1. This is another example of alternating series. And here next one, conditionally convergent series. The series summation of an is called conditionally convergent or semi-convergent. Here conditionally convergent or semi-convergent if summation of an is convergent. Remember, summation of an is convergent and summation of an is convergent if summation of an is convergent but summation of modulus of an is not convergent. Remember the word here, summation of positive terms of modulus of an means positive terms of an not convergent. Means if I take, suppose if I take one example here, you can take summation of an, I will write for summation of minus 1 to n into n. Here that is n minus 1, if I take first term is plus 1, minus 2, plus 3, so like that it is going on. So but here if you take a positive terms, suppose if I take a summation of a1, modulus of a1, modulus of a2 means positive term of first term, positive term of second term, this series not convergent. But here summation of an, this is convergent, but summation of positive terms does not convergent. This is the definition of conditionally convergent series. So the examples are here for the conditionally convergent series. So how we check? So these are the just an example. So after solving, we'll get is it conditionally convergent or not. So first of all, I already checked these conditionally convergent or not. Then I given these as an example for conditionally convergent. So we will discuss later on the examples on conditionally convergent. So now absolutely convergent. After conditionally convergent, we should go for absolutely convergent. So absolutely convergent means the series, the summation of an is said to be converge absolutely. Here I am taking summation of an is said to be converge absolutely if the series summation of modulus of an is convergent. Here the exactly opposite of this. Here it is convergent in the all the positive terms series in the summation an is convergent, but here all the positive terms of a summation an is not convergent. So the difference between absolutely convergent and conditionally convergent. Here the examples for absolutely convergent. So when we solve the examples or to check the convergence of the examples, then we can conclude that is it absolutely or conditionally convergent. So now here two very important three notes are there. Observe here, an absolutely convergent series is convergent and its converse is not true. See, always the absolutely convergent, here absolutely convergent series is always convergent. When we prove conversely means all the convergent series are absolutely convergent. So its converse is what? Its converse is all the means every convergent series is conditionally convergent. This is not true always. So but if it is absolutely convergent, it should be convergent first. So therefore an absolutely convergent series is convergent and its converse is not true. And second one, notice if summation an is absolutely convergent series, then the series of its positive terms and the series of its negative terms both are convergent. Very important note it is. So this is a one mark question in the KUD entrance examination. They may ask this question. Summation of an is absolutely convergent series. Then the series of its both positive and negative terms are convergent. And next, third condition is the summation of an is conditionally convergent. Then the series of its positive and negative terms, it means both the positive and negative terms are divergent. Here the difference is absolutely convergent series. In an absolutely convergent series, both the positive and negative terms are convergent. In the conditionally convergent series, both the negative and positive term series are divergent. So this is the some definitions on the alternating series. After this, we can see the Leibniz test for alternating series in my next lecture. Thank you.